Alright guys, so now we're looking at 9.6, which is the surface area and volume of similar solids. And the key thing we're going to hone in on here is something called similar solids. So we kind of did this back in 9.2, I think. Or actually, I think it was in Unit 8 that we did this, where we had some similar figures and we had to find the perimeter ratio and stuff like this to help us define the area ratio and so on and so forth. So just to recap, if we are given a similarity ratio where it's A to B here, so in order for us to find the area, remember area is always measured in squared units. So that means I would take the similarity ratio and I would square it. So it would be A squared and B squared. Okay? Now to find the volume of that, I would take the similarity ratio, and we know that volume is always measured in cubic measurements here. So that means I would take the similarity ratio and I would cube it instead of squaring it. So remember, to take the area, I would square it. To get the volume, I would cube it. So for instance, let's say I had the similarity ratio. Let's just do something easy. Let's say I had a similarity ratio of 2 to 3. Okay? So that's my similarity ratio. So to find the area ratio is I would take the similarity ratio and I would square it. So 2 times 2 is 4. 3 times 3 is 9. So my area ratio would be 4 over 9. And so now to take my volume ratio is I would take the similarity ratio and I would cube it. So 2 times 2 times 2 is going to be 8. 3 times 3 times 3 is going to be 27. So that means my volume, my area, my similarity ratio, that's how it would work on all three of those. And the one vocabulary word that you have on your notes is going to be similar figures have the same shape and all of their corresponding parts are proportional. So now let's go and flip over and let's look at some examples here. Okay, so on the first example, it says here that the two cones are similar figures, so these two cones are similar figures, and what we need to do, we need to find the similarity ratio, the area ratio, and the volume ratio. So we need to find all three of those ratios to help us define this. So right now, all I literally have to do is pick any two of the measurements, it doesn't matter. So I can either do 3 and 9 or 8 and 32, it doesn't matter. So I'm just going to pick 3 and 9. So 3 over 9 is going to be my ratio, and the first thing I have to do is I have to reduce that. So I know 3 and 9 can both be reduced by 3, which I can just type in the calculator to give you a reduced fraction. So 3 divided by 3 would be 1, and 9 divided by 3 would be 3. So that means my similarity ratio is going to be 1 over 3. So now, if I wanted to find my area ratio, all I have to do is take my similarity ratio and square it. Because remember, area is always measured in squared units. So that means I would do 1 squared, which would be 1, and 3 squared, which would be 9. So my area ratio would be 1 to 9. And then lastly, to find my volume ratio, all I would have to do is take the similarity ratio and cube it. Because remember, volume is always measured in cubic units. So I'm actually going to write this down here. To find the volume ratio, I would take 1/3 and I would cube it. Squared is here, and I would cube it. So 1 times 1 times 1 is always going to be 1. Then 3 times 3 times 3 is going to give you 27. So 1 over 27 would be your volume ratio. So that's how you would end up finding the similarity ratio, area ratio, and volume ratio inside these. Okay, so on my first example here, it is telling me to find my area ratio, actually it's telling me to find my similarity ratio and my volume ratio if the similar prisms have surface areas of 144 and 324. So literally all I have to do on this is I have to take this, set it the biggest one over the smaller one, and then I need to find my similarity ratio and my volume ratios by using both of these here. So literally all I have to do is take 144 and put it over 324. So I told you guys that area is always measured in squared units. So I know if I'm going from my similarity ratio to my area ratio, I'm going to square it. So now to go back to my similarity ratio, I have to take the square root of this whole thing. So if I take the square root of this, the square root of 144 is going to be the square root of 144 is going to be 12. And the square root of 324, let me do the square root of 324 here. The square root of 324 is going to be 18. So now I have to reduce the ratio. So if I did 12 over 18, that's going to end up giving me 2 over 3. So ladies and gentlemen, this would end up being your similarity ratio right here. So now in order for me to find my volume ratio, is I would take the similarity ratio and I would square it, or I would cube it. Because remember, volume is always measured in cubic units. So I'm going to do 2 over 3 here. I'm going to do 2 over 3 here, and I'm going to cube it. So 2 cubed is going to be 2 times 2 times 2, which is going to be 8. And 3 cubed is going to be 3 times 3 times 3, which is going to be 27. So this would end up being your volume ratio by cubing it. And so we're going to end up being able to use these to find the volume and area when given one and needing to use it. Alright guys, so now in the next example, we are given the volumes of 2 similar solids. And then what we need to do is we need to find the similarity ratio and the area ratio using these 2 measurements here. So obviously what I always do the biggest one over the smallest one. So I'm going to take the biggest, or the smallest one, which is 1,728, and put it over 3,375. And so now I know if I'm going to volume, I'm going to take the similarity ratio and I'm going to cube it. So now in order for me to go backwards is I need to take the cube root, which means I'm going to stick a number 3 up here in the top right hand corner when I plug this in the calculator. And so whenever I do this, the cube root of 1,728 is going to be 12. The cube root of 3,375 is going to be 15. So you'd end up getting 12 over 15. But then whenever I plug 12 over 15 in the calculator, it is then going to reduce even further to be 4 over 5. So the smallest fraction, this is going to be your similarity ratio, which I would use it to find missing sides, to find missing perimeter, and stuff like that. So now, the similarity ratio, in order to go to area, I know area is measured in square units. So I would take the similarity ratio, which is 4 over 5, and I would square both of those to end up getting my area ratio. So the area ratio is going to be 4 times 4, which is 16, and then 5 times 5, which is 25. So the area ratio is going to be 16 over 25. Alright guys, so now for the last example, we are going to take actually what I just talked about in the previous examples, and we're going to put it into use now. So basically we're going to have to end up finding my similarity ratio, and we're going to turn that similarity ratio into volume, and we're going to use that volume ratio to find one of the missing volumes. So what the question says to do here is the 2 cylinders and the 2 cylinders are similar, and the volume of the larger figure here is going to be 1,357.17 units cubed. So that's going to be the area or the volume of this guy. So right now, yes, technically I could use these 2 measurements to find the volume, but I'm actually going to show you how this ratio works to use the volumes here. Okay? So right now it says we need to find the volume of the smaller figure. So I could either use 5 and 6 or 10 and 12, it doesn't matter. I'm going to take the units 5 and 6 and I'll put them over each other. So first I would do 5 over 6 and I would see, can those reduce anymore? No, they can't. 5, nothing can go into 5 and nothing can go into 6. That's the same, they'll go into both. So basically this is going to be the lowest form. So this is automatically going to be my similarity ratio. And so what it tells me is it wants me to find the volume. So I know if I want to get my volume ratio, I have to take the similarity ratio and I have to cube this sucker. So that means 5 times 5 times 5, if I did it, would be 125. And then 6 times 6 times 6 is going to end up being 216. So ladies and gentlemen, my volume ratio is going to be 125 over 216. So now I'm going to use this ratio and use the volume I already know and set them up equal to each other to help me to find my missing volume of my smaller one. So I always do the smaller one over the biggest one. So the bigger is going to be, or the smaller is 125 over the bigger, which is 216. And then all I would do is I would put this on the bottom over here because this is my smaller one. and then I would put it over x, because that's going to be my, or this is my larger one, and I'm going to solve for the bigger, or the smaller one here. So now all I have to do is cross multiply and divide, so I would multiply these two guys here, and then I would end up dividing by 216, and I would solve my cross multiplication here. So right now, x is going to end up turning into 785.4 units cubed, because this is in units measurement. So after I cross multiply and divide, it turns out to be 785.4 units cubed.